Okay, we'll try this again. Facebook hates high definition. Always says my videos are too long. Welcome to Cam Power Sports, 801-686-4556. What we have here is a YFZ 450 head. It's had some port and polish work done to it to the level of blueprinting. Nothing super extreme, no flow bench work, but definitely good casting cleanups. This guy rides this thing mostly at the sand dunes and was looking for a good complement to his exhaust system. And of course it all starts with, as we term, blueprinting. It's kind of funny, there's some local shops around here that dictate that blueprinting is measuring everything in your engine and identifying everything in your engine and writing it down so you know what you have. This head is a good example of what blueprinting really is. Anyway, so to get started, we'll just start with the combustion chamber here. It's easy enough to see. As you can see around these valves, I've smoothed it out quite a bit. When they machine it for the valve seats, the engineers engineer for ideal, and then there's the real world. There is a big lip where the cutter clears to machine the pocket for the valve seat to be pressed in. That's on every valve, and it goes all the way around. That's restrictive and upsets the flow a little bit. They've deemed that acceptable, and they do not spend any extra time other than machining the pocket and pressing in the guide. What you have to do is gently, without taking any material off, any undesirable amounts anyway, gently roll that right angle back and blend it with the combustion chamber shape and radius everything out. As you can see right here, the pocket was a little bit deep. We did not feel okay hogging it down until it was gone. We have a substantial improvement, and that's basically what you're after, is a good blueprint. You have to be careful. You don't want to just go in and take everything off that you can until it stays good. Another key factor is right here where the O-ring for the cylinder head passes by these corners. It's important not to get too close to that as well. You'll burn out head gaskets if you're lucky enough to get them to line back up on the initial reassembly anyway. So basically there's your gist of your combustion chamber. Just radiusing those pockets back and bleeding it out and rolling everything into nice smooth flowing transitions without changing the shapes too much. Going into the ports, again, the back side of the valve seat, same story. Let me see if we can zoom in here a little bit. Okay. Alrighty. Here we go. The back side of the valve seat, same story. They cast the cylinder head, then they put the valve stem holes in place, and then that's the center line for everything. Oftentimes there's either a relief in the casting underneath the back of the valve seat or a protrusion where it rises up the valve seat. Again, back to the some is good, more is not better analogy. You don't want to just go in there and start taking off all the material you can, but you definitely can use your valve seat ring as a guide or a template and carefully blend the walls of the bowl in the aluminum casting around it so that you get a nice smooth transition between your port and your valve seat. And that's about the best you can do with that there. There's definitely more mods that can be done here, especially with your valve guide and this pocket area, but for this level of porting, this is totally sufficient. And without freehand, anything more than just your freehand work would require flow benches and CNC, not CNC, but flow benches and measuring burrets so that you know that you're getting everything done correctly and true. You can definitely go backwards with this mod and lose more power than the original stock location, the original stock setup, if you go in and just start hogging everything out and taking too much off. Just like with my two-stroke video, intake ports, I'm not a fan of polishing them. There's several reasons why. The biggest reason why is fuel atomization. Your fuel's heavier in your air and has a tendency to separate and fall out. If your ports are smooth, your fuel's going to remain puddle form and just run into the cylinders as flooding. You'll have mid-range flat spots, top end coughing, reduced RPMs, poor idling, hard start, to name a few things on the list. Usually sandblasting gives a sufficient enough texture, and that's what I do on a lot of cylinders. Is I go ahead and do my work and then just sandblast the intake sides, and that's good. If you do leave a grain like I did on this one, you want to have your grain cross patterned so that the fuel has the ability to reatomize. That is the #1 mistake in previous port jobs that I see come into my shop, and so many builders just go in there and start wallowing stuff out as big as they can see fit and polishing things until they're smooth. Good concept, poor application. Intake runners need to be coarse and need to have the correct grain pattern. Takes a lot of practice to get that right, but it's definitely something that can be done at home. And if you're paying for these services, the reason for this video is both to educate the home guy, and also if you're not interested in tooling up and getting the correct tools and spending the time of doing it yourself, to ensure that you know that you're getting what you pay for. So if you drop off your cylinder to somebody and pay the money that they require to do a port job, and you pick it up and your intake runners are smooth, get a refund. Give us a call. We'll see if we can fix what damage they've done for you. Okay. Same story with the backs of the bowls. You don't, like I touched bases with the valve seat area and the transitioning, you don't go in and hog out as much as you can. There's a lot involved there. The bottom line is, chances are, with a multiple cylinder engine like this one, the first thing that's going to happen is with a freehand, you're probably going to knock it so far out of balance you're going to disrupt the ideal flow that's been engineered to the thing. The second thing is, when you start opening things up, unless you do it correctly with a flow bench and shoot for a goal and a specific flow amount per given time, chances are you're going to add some form of aerodynamic restriction. It may turn the corner and slow down, and a lot of people don't realize it, but air is more like snot. It slides along with high friction, and so anytime you have a restriction, it compounds, and it's like stretching rubber, so to speak, pulling air through a chamber. So you definitely don't want the air to slow down at all. And that leads on to the exhaust side. We've talked about intake and texturing. Exhaust is quite different, and we do a little bit more with our polishing than per se this one. But this is for a good this is for a good sand dune bike, and just to complement his exhaust. Exhaust, you can polish it. It's waste. Polish it as much as you can. Same story with removing material. Take as little out as possible. Don't change geometry, but get in there and just polish it up and slip the exhaust out. In the exhaust tunnel, you can sharpen the dividers as well as the intake tunnel. Do not change their geometry. Do not try and change their angles. Be careful how much you sharpen. It's pretty hot in here and things have a tendency to crack. Let me see if I can grab the light and get a little help in this tunnel and get a little bit better view of that divider here. Bear with me. Okay. Let's see here. There we go. That gives you a little better idea of that divider. Notice I didn't do it razor sharp. It's tapered up. We didn't really take any material off the valve guides, unnecessary material off of the valve guides themselves for this particular application. There is more work that you can do with that area. We'll save that for a more extreme port job and touch base on that at a later time. But there's several reasons why we did not take away from that valve guide area for this particular application. This is basically a good level of blueprinting for a 4-stroke cylinder head. There's a lot of casting cleanup you can do. You don't need to go in and hog everything out like I keep reiterating. That's important. You don't want to change any of the flow engineering. you're just after cleaning up what the assembly line said that's good enough. And that's going to make a good responsive throttle response, complement a pipe, flow to the best technology. It's pointless to spend the extra money that it is on pipes and stick them on assembly line components. Definitely complements an exhaust system and makes your dollar go its farthest. For any questions, we can be reached at 801-686-4556. This is Nate with Cam Power Sports, and thanks for looking.